number 1, and we are going to solve problem number 1 that says that the sides of a square are increasing at a rate of 1.5 millimeters an hour. The question of the problem is, at what rate are the area and the perimeter increasing at the instant that one side is 28 millimeters? First of all, we need to identify the information given. So here we know that dA over dt is 1.5, that is the same as 3/2. And dA over dt is equals to a prime of t. Here is our square, and a represents the sides of each.
Hi, my name is Karen and I'm going to present the part of the area of our problem. We know that in a square, a is equal to a to the square. But on this case, it also depends on our variable, that is the tan. So what we actually have is this formula that we have to divide it, that is right here. What we need is the rate of change of a, that is here, and we have to do the variable that it will be here. Using the chain rule, so moving on the differentiation of the function, it will be that a multiplying a to the tan, that is our variable. So we have this formula and we just substitute our data over here and do it. So we will have that a derivative on the variable of time. It will be 84 millimeters to the square over hours. That will be our rate of change of the area.
We know that in the square a equals 4a, but in this case it works the same as in this diagram. It's that formula. So the same procedure is applied as when solving for area rate of change. So we derive this and we obtain 6 millimeters over hours. This result can be proved just by thinking that every hour the side of the square increases by 1.5 millimeters. So as with the square as 4 sides, at any given time the rate of how the perimeter increases will be 4 times the rate of increase of the side, and 1.5. The result will be 6.
In order to graph dA over dt as this, we have two variables without assuming the side is 28 millimeters. The graph won't be possible, so if we plug the 28 millimeters in the data result, we'll be able to graph y is equal to 84. The following graph represents dP over dt, where the x-axis represents time in hours and the y-axis represents the rate of change of the perimeter of the square.